software for Sensieve. I hear noises, but I don't see slides. Oh, it works. Cool. So there are 4 companies involved. The guys doing the hard work are a company called Resertech. They're involved in Earth observation data, so using satellites or UAVs to try and derive information about assets. They work a lot in the water and agriculture sector. University of Birmingham, we've got a multidisciplinary team. I'm hoping Loretta is somewhere in here. There she is. Sorry. So they're primarily bringing some geotechnical expertise into the project and doing some slope failure monitoring. I'll get into the nuts of the project in a minute. Sensieve, that's us. We provide wireless condition monitoring systems to the rail and construction industries. I suppose in this day and age you would call us an IoT company. Am I? That'll be it then. This is hardware, not software. I'm a software engineer. And Amy, who are the omnipresent big UK FTSE company. Amy Consulting are the arm that we're specifically dealing with. I've got Craig over here, who's helping me out, and they're primarily concerned in trying to exploit the technology that I'm about to introduce. Okay. And they're primarily looking in rail, highways, utilities, that sort of area. And I think they've started, as of last year, the Wales and Borders contract. So they run parts of the rail network. So in a nutshell, the title, which I'm going to condense into the acronym SSAAMS, what we're trying to do is try and identify and manage risk in assets. Traditionally, you would do this using a walkover technique. So you'd send an engineer over your asset, and maybe once a year they'd say, yeah, it's not going to fall over. That's good. Sensieve come along with wireless IoT systems, industrial IoT systems, to try and take that person away from the asset, or instead of every 6 months, maybe every 5 years, then they're required. And that gives you real-time data as well, rather than a data point every year. And there's also, you can use satellite-based observations in order to do some mass coverage. The technique that I'm about to introduce is something called interferometry, InSAR. So the idea is that you use satellites to cover a large area, and you identify areas where there might be some motion. And then potentially you've also got this idea of data analytics, which someone would come in, be clever, you give them some data, they do some processing, and something would come out of it. So the idea of this Innovate UK funded project is to bring all that together, understand how everything complements each other, and to understand the relationship between the data that we're gathering from walkovers, from sensor data, from satellite data, and try and relate that to a level of risk, a numerical 1 to 5, something like that, red, amber, green, that sort of idea. And because Sensieve have been around for about 15 years, and the Sentinel-1 satellite has been around for a couple of years, it's given data since 2015, we have the ability to harness historical data that we've captured, which enables us to hone the methodology going forward. Okay. So I'm not a satellite monitoring expert. That's what Resertech are there for. Fortunately, they can't be with us today. But the idea is that, if this gives me a laser, the idea is that this satellite is passing over the UK twice, once every 6 days in 2 different directions. And it's giving you a really wide area of settlement data primarily. So you're looking at, if something moving up or down. You get global coverage using the satellites. So it's not like it's targeted at a particular area. And as I said before, it goes back to 2015. The idea between InSAR, and I've written it down, it's interferometric synthetic aperture radar. That's what InSAR stands for. The idea is that you have a satellite shooting a radar beam at an asset. It comes back with a wave return, and the phase shift allows you to identify whether or not something has moved. So it's ideal for more long-term trends because you're taking measurement every 6 days. If your earth embankment slips onto a railway or a highway and you learn about it 6 days later, then that's not very good. But it allows you to capture more rapid changes than if you've got a steered satellite where you have to pay somebody a lot of money and then you're in a queue before you can actually get your data. What we want to do is we want to have a symbiotic relationship. So we want the satellite to identify where we want to put ground sensors. We want to calibrate the ground sensors using satellite data. So it's kind of hand in hand. Just quickly go over the sensors that we use. So Sensieve have a wireless platform. So there's no wires. It's quickly deployable. You put it in your van, you drive to the site, you install it, and you walk away. All of the installations that we did, I'm going to go through 3 case studies where we actually deployed sensors and then looked at satellite data. They were all installed in one shift, which is a great win. We have tilt sensors and displacement sensors that give you motion, but we also have geotechnical sensors. So we have the ability to look at the full suite. So looking under the ground using piezometers or extensiometers, that sort of thing. And the great thing is that you can install the sensor, you take a reading every half an hour, and you'll get a 12-year battery life, which is great because you can leave it there and you can forget about it. You don't have to go on site to replace batteries, to maintain solar panels, that sort of thing. And if you need to, we have the technology to be able to increase that reporting remotely. So you don't have to go on site in order to take more measurements or less measurements. We can go down to 1 hertz, so that's a measurement every second. So that gives you a bit more dynamic motion. So for 3 case studies, I'm going to blitz through them because I probably haven't got much time. We've got, this is Kent, Southeast England, and you can see that what we've done using the InSAR analysis is identified railway assets, so that's the black line. And these red areas are areas where we think that we've identified some settlement. This area here, this box, is somewhere where Sensieve were contracted out to actually monitor a seawall near Dover, which had collapsed in 2015. So we were brought in after the collapse to monitor the asset whilst workers were on it. And we saw that there was some settlement in the middle. And bearing in mind this is historical data, this is before the project started, we've taken that information, done some InSAR analysis, which is this black line here, and we've identified that there is a potential area of settlement. So that lines up quite nicely. There's not, in terms of correlation, there's not a particularly high correlation, so we can't say for certain, but we can infer based on that graphic that we're measuring more or less the same thing. And this is a good way of identifying, on this slide here, we're identifying areas where there might be a problem, so we deploy sensors. It just so happens that we already have sensors there. Case study number 2. This is a reservoir with a dam wall, earth wall with a stone lining to it. Northumbria Water, who are the owner of this dam, wanted to know what happened as the water charged and discharged in the reservoir, what's happening to their dam wall? They do a walkover once a year, and they have a surveyor traipsing up and down. It's very windy. The wind gets up to about 70 miles an hour there. It's out of the way. It's in the middle of nowhere on the Scottish border. And what we did was put some tilt sensors on the wall. That allows us to look at the lateral motion of the wall, whether or not it's going in that direction, and whether or not it's also settling. We can infer that from the sensors. And obviously this satellite is overpassing every 6 days, and this site is great because the satellite has a particular orientation where it's looking as an ascending and a descending pass, so you can look at it from different angles. But if you're looking at a slope, if you're not going at the slope at a particular angle, then you can't see the slope. So same with a total station or whatever. So this is a great example because the satellite's pointing in the right direction. Here's some data. You can see that our baseline, there's no movement. This is on the 12th of November. And then as we take slices of the profile, so this is the profile of the wall, as the season goes on, so it starts settling in the middle. And the cool thing is that we installed at this date here in 2018, but because we're using a satellite which has data for the last 2 years, we can go back in time. We've got the water level of the dam from Northumbria Water, that's that blue line there, and we've got the settlement from the satellite data. And you can see that water goes up, dam goes down. It's a nice little trend, and most importantly, the sensor observed displacement matches the curve of the satellite. So we're looking at the same thing, and we have a certain degree of confidence that what Sentinel is observing using the persistent scatterer method is what is actually happening on site. One final case study, because I've only got 2 or 3 minutes. We've got an earthwork here, again, next to a dual carriageway. So cars are going 70 miles an hour, and we've observed here that the asset owner, who is Highways England, has observed that this slope is slipping. So we've got University of Birmingham involved to try and do some analysis on the slope to look at some failure mechanisms that might be in place. And the InSAR analysis shows that what you'd expect, which is that the toe is bulging. We're seeing more material at the toe, and we're seeing less material at the top. What we've done is this is a tilt meter on a stake, and we've deployed these on network rail sites primarily in the past. So we offered this to Highways England. They said that's great because if it slips, we'll know about it. So we've put 2 rows of stakes in here, and we've observed a little bit of movement which coincides with the analysis here. Okay, so I just want to quickly go through the sorts of ground sensors that you would want to use on this sort of project where you're trying to deploy ground sensors and satellite. So we talk about tilt meters, optical displacement sensors, that's using a laser to determine distance. Soil moisture is quite important if you're talking about earth slope. Geotechnical sensors, unfortunately we didn't get a chance to actually use any, but the deep-seated rotational failure which we're seeing here, in order to get a bit more information on that sort of slope, ideally what you'd use is a geotechnical sensor to get a bit more context about what the ground is doing. And we also offer some static imagery. So if something is likely to fail, we point a camera at it. If the sensor detects a movement, the camera takes a photograph, that gets sent back to the route control, and they can close the road, close the railway, evacuate, whatever they need to do. And what we're doing is sending data every 15 minutes. So there's a portal sat there. Anyone can log in at any time, log in and look at the current state of their asset. That 15 minutes can be reduced further if you need to. It's just that because the gateway is a solid power solution, it makes sense for it to be every 15 minutes. But we can reduce that to live data being streamed into the portal for a period of time, 2 weeks if necessary. Okay, so quickly Blitz release slides as well. The idea is that you think big, you've got a wide asset, you use some standardized algorithms in order to identify hotspots when you go a bit deeper, and then if you need to, you put sensors in. So although I'd love to put sensors everywhere, all over the UK, it's just cost prohibitive to do so. So you use InSAR analysis in order to do that identification, and potentially in this situation, if you see that there's the movement is controlled, then you can take those sensors out, you can put them elsewhere. So finally, this is the last slide. This is just an idea of the tiered approach that you do. So it's just another look at what we said before. So wide area, doing a hotspot, and then having a site-specific analysis. That's where you take all of the information that you have available to you, and then you get the trained professionals, the geotechnical engineers, the site managers, all around the table, look at the data, and then make a decision based on the risk that's been identified. Okay? So, thank you very much.